Hello students, the topic which we cover in today's video is Parsevals Theorem. So we will be covering this topic in two sections. One is Parsevals Theorem for energy signal, another is Parsevals Theorem for power signal. As you know, there are two types of signal. One is known as energy signal, another is known as power signal. The signals which are energy signal are having finite energy and zero power, whereas the signals which are power signals are having infinite energy but average power. So first we will see the Parsevals theorem for energy signal. So for that, just see if Ft is an energy signal, then energy is finite, which we can write it in this form: 0 is less than E is less than infinity. That means it will be in some finite range, and P is equals to 0. That is, power of that signal is 0. So the formula for energy is E is equals to minus infinity to infinity F square T dt, where Ft is an energy signal. So by this formula we can calculate the energy of the signal. So F square T can now be written as Ft into Ft. So that is minus infinity to infinity Ft into Ft dt. Now this Ft is the formula for inverse Fourier transform. So instead of this Ft, now I will write the formula for inverse Fourier transform, which is 1 by 2 pi minus infinity to infinity f omega e raised to the power j omega t d omega. So this square bracket section is nothing but a single Ft. Now this is minus infinity to infinity Ft. This is Ft and dt. Now interchanging the order of integration. So after rewriting this E can be written as now E is equals to 1 by 2 pi minus infinity to infinity f of omega minus infinity to infinity ft e to the power j omega t dt and d omega. Now minus infinity to infinity ft e to the power minus j omega t dt is nothing but the formula for f of omega. So now I can write it in this way: minus of j into minus of omega. So that means your Fourier transform f omega is now f of minus omega. Again I can explain you. If it is minus infinity to infinity ft e to the power minus j omega t dt, it will be f of omega. So instead of minus omega, it is plus omega. So that means the Fourier transform f of omega will now be f of minus omega. So this whole thing will become f of minus omega. The remaining part is 1 by 2 pi minus infinity to infinity f omega d omega. So this is f omega and f of minus omega. For a real ft, if ft is a real function, then f omega and f of minus omega are complex conjugate. You know the concept of complex conjugate. If suppose f omega is a plus jb, that means f of minus omega is what? A minus jb. That means if you take the mod of that, a plus jb will give you under root of a square plus b square, and a minus jb will also give you under root of a square plus b square. So that means f omega and f omega both are known as the complex conjugate of each other if the function ft is a real function. So f omega and f of minus omega can be written as mod f omega whole square. So instead of this f omega f of minus omega, now I will write mod f omega square. So this is E 1 by 2 pi minus infinity to infinity mod f omega square d omega, or you know that omega is equals to 2 pi f. So instead of omega, if I write 2 pi f, so it d omega will become df, and this 2 pi will get cancelled with this 2 pi. So you can also write E is equals to minus infinity to infinity mod f omega square df. So this equation is known as Parsevals theorem for energy signal. So suppose in the exam they will ask, explain Parsevals theorem for energy signal. This much you have to explain. Now this mod f omega square represents energy per unit bandwidth, and it is also known as energy density spectrum or energy spectral density, or in short ESD. So suppose in the exam they will ask, explain ESD or explain energy density spectrum. So then also you have to explain all this thing And finally you will write that mod f omega square is nothing but the energy density spectrum of this particular signal. So this is Parsevals theorem for energy signal. Now we will see what is Parsevals theorem for power signal. Next is Parsevals theorem for power signals. Power signal is one which has infinite energy and average power. In the previous case, energy signals, the signal was having a finite energy and zero power. But when the signal is a periodic signal, that means a signal which repeats its value after a particular interval of time. So such type of signals are infinite signals, so obviously they will be having infinite energy. So periodic signals energy cannot be calculated as it is infinite, so we will calculate their average power. So it can be calculated by the formula P is equals to limit t tends to infinity 1 by t limit over minus t by 2 to plus t by 2 f square t dt. So for periodic signal, the function can be defined by its Fourier series, which is defined by summation n is equals to minus infinity to infinity Cn e raised to the power jn omega naught t, where this Cn is 1 by t integral over the limit minus t by 2 to plus t by 2 ft e to the power minus jn omega naught t dt. So this way we can calculate, by this formula we can calculate the value of Cn, and then this value of Cn will be put in this. So we will be forming our function for a periodic signal, and then we can calculate the Fourier transform of such function. So power over a cycle is expressed. So let us express the power over a limited period of cycle from minus t by 2 to plus t by 2. So it will be defined by P is equals to 1 by t integral over the limit minus t by 2 to plus t by 2 ft into f abstract t dt. So that means f square t is, I am dividing it into two parts. One is the real ft, or you can say one is the plain ft, and this is the complex conjugate of ft. So suppose if ft is a plus jb, then f abstract t is a minus jb. So that is the complex conjugate of the signal. So now P is equals to 1 by t minus t by 2 to plus t by 2 f abstract t, and instead of this ft, now I will put this thing, which is summation n is equals to minus infinity to infinity Cn e raised to the power jn omega naught t dt. So now interchanging the limits, P is equals to summation n is equals to minus infinity to infinity Cn. I am keeping it outside the integral. Then 1 by t integral minus t by 2 to t by 2 f star t e raised to the power jn omega naught t dt. Okay. So as you can see that Cn is equals to 1 by t minus t by 2 to plus t by 2 ft e to the power minus jn omega naught t dt is your Cn. So now if this e to the power something is positive, so this Cn will become C of minus n. So this will become P is equals to n is equals to minus infinity to infinity Cn, and this part will become C of minus n, which can be written as mod of Cn square. So this above equation is Parsevals theorem for power signal. Mod I have taken because if a function that is a plus ib, mod of that is under root of a square plus b square, a minus ib, again mod of that is also under root of a square plus b square. So that way we can write it in this way, Cn minus n can be written as mod Cn square. So this equation is known as Parsevals theorem for power signal. So this is Parsevals theorem for power signal. Now we will see the power density spectrum. Now after the Parsevals theorem for power signal, let us see the power density spectrum concept. You can see two waveforms here. This waveform is an periodic signal denoted by ft, and this periodic signal is truncated at a particular time limit from minus t by 2 to plus t by 2. So this is a finite duration sequence. So we have truncated this infinite signal to a finite value. So that is why we have denoted this signal as FTT, F truncated T, or truncated FT signal. So now this is a finite signal. That means we can calculate the energy of this signal, which is E is equals to minus infinity to infinity Ft square T dt. or ft omega square df. This we have already seen in the energy density spectrum or Parsevals theorem for energy signal. So this you already know. Now ft within the interval minus t by 2 to plus t by 2 will be same as ftt within the interval minus infinity to infinity. That means what? This is ft. If we truncate this signal from minus t by 2 to plus t by 2, it will become ftt. And if we increase this minus t by 2 to plus t by 2 to minus infinity to plus infinity, this truncated function will become ft. So that is what I have written in this line. So minus infinity to infinity ft square t dt is equal to minus t by 2 to plus t by 2 f square t dt. That means this complete function is between the limit minus t by 2 to plus t by 2 or truncated function within the limit minus infinity to plus infinity, both are same. So now 1 by t minus t by 2 to plus t by 2 f square t dt as in power can be replaced with minus infinity to infinity ft square t dt or minus infinity to infinity ft square omega df. This is in the time domain. This is in the frequency domain. So now p is equals to limit t tends to infinity 1 by t minus t by 2 to plus t by 2 f square t dt. This is the formula for power. Now this ft will be replaced with ft of omega or ft of t. So this will be minus infinity to infinity ft omega square by t df. So this part is known as the power density spectrum, and out of this part ft omega upon t is denoted by s omega, which is known as power density spectrum or power spectrum density, or in short PST. So they may ask in the exam either explain Parsevals theorem. So in that case you have to explain both Parsevals theorem for energy as well as Parsevals theorem for power, or they may ask Parsevals theorem for power signal specifically or Parsevals theorem for energy signal specifically. Then in that case you just need to explain that part only. Or they can ask explain PSD, explain ESD. So in that case also you have to explain all this thing. So I hope the Parsevals theorem's concept is clear to you for both energy signal as well as power signal. And if you have any doubt, you can write in the comment section so that I can explain further and clear your doubt.